Hello and welcome back to Kerbal Space Programming, where in the last episode we put a bunch of satellites in orbit, but now it is time to do more things. Let's jump into the contract building and see what things we could possibly do. Ferry of VIPs, blah, 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 place more satellites. We've already put up satellites. Fly by the moon. I think that is what we shall do today. We choose to go to the moon and do the other things. Well, not the other things. Let's not do the other things. Let's go to the moon. To the moon, you say? Well, I have a craft that is ready to do just that. We're using a very similar launch stage. I think I've added maybe another fuel tank or two just to make sure we get up into orbit. We've got a bunch of science here, and underneath these parachutes, we've got a smaller probe core that we were able to unlock. And we've got our scriptable control system here, and we've got two communications antennas. So this communications antenna only can turn on when we are out of the atmosphere, because otherwise it will get ripped off. But this one can stay on while we are in on the launch pad and close to the Space Center. And that's going to be important because we are going to revamp our boot script. But before we do that, let us throw this on the launch pad and see what happens. And here we are on the launch pad, and our craft is going to do absolutely nothing. No, we have revitalized our boot script. In the past episodes, we've either put a whole bunch of get to orbit and various commands in our boot script, or we will just open up this terminal and type stuff in directly. But to be honest, that feels a little cheaty to me, and that's not typically how missions are done in the real world. Typically, you'll go ahead and upload a whole bunch of instructions whenever there's a connection, and then you'll say, run that. So we have revitalized our boot script, and let's go ahead and jump over and take a look at that. So here we have a generalized boot script, and the idea is that this can be the boot up script for every craft that we send out from here on out. And we may make some adjustments as we go on, but I'm going to kind of step through this. So if you think about your regular computer, that you turn it on, and what does it do? Does it try and go to space? No. It just loads up the various files that it needs to figure out how to run your monitor and how to launch whatever operating system you have installed, and then it lets those other files that you may have saved go ahead and do their thing. And that's what we're going to try and do here. First, we're going to go ahead and do the set ship control, pilot main throttle to 0. That's the default throttle when we load up the craft. And we just want to say, if we're not running a script, please don't throttle up. So this will make sure that we never end up accidentally firing our engines when we don't mean to. And next we've got a whole bunch of functions, and I'm going to try and go over these pretty quickly. Again, all of this code is available. There's a link in the description if you want to check up on it. But first we've got this function called hasFile, and we're going to use this to check if a particular file exists on a volume. So remember, in the past episodes we've talked about that there are a couple of volumes, provided that we have access to them. The archive volume, which is the one that we have on the that we can actually throw into our file system, and this is the file system at Kerbal Space Center. And then there's the actual hard drive space on the ship itself. So ship, and this one is has an index of 1, and these values are always going to be the same. So what this function is going to do is it's going to say, okay, I'm going to take a name, I'm going to take a volume number, I'm going to switch to that volume, and then I'm going to list all the files in that volume and put them in this variable called all files. Next, I'm going to do a loop over all files. I'm going to say for every file in all files, I'm going to say if the file name is equal to name, and this is the name that we passed in here as our parameter for hasFile, then I'll say switch back to the current volume and say, yes, we found it, this file does exist. And if not, we're still going to switch back to the ship's current volume, but we're going to return false. So if we had a file on the current ship, then we could say, hasFile, does it exist? .ks, and would say we're looking for it on volume 0. So the volume at KSC, Kerbal Space Center. Now, of course, if we don't have a connection to Kerbal Space Center, then this is going to have a problem. But we could also do this. We could say check and see if we have it on our existing hard drive on the actual rocket, and then this will return, true or false. So these are a bunch, we're going through a couple of just helper functions that we're going to need throughout our boot process, and maybe in some of the other scripts that we'll get into. So this is a delay function, and I'm not going to spend a lot of time here because I'm still kind of working on it. But the goal is, if we imagine right now there's the satellite New Horizons that's orbiting, it's getting close to orbiting Pluto. And we can't just say, here's a whole bunch of instructions, please go do that, and have it do it right like that, right? Because there's the speed of light problem. We have to transmit all of these instructions and wait for it to receive them all. So I've added this delay function that's going to try and simulate some of that based on distance, but I'm still doing some reading and we may tweak that. So I'm going to kind of skip over this. Right now, basically, it's going to say that we're going to wait 3 times the speed of light from our current rocket to the Kerbal Space Center if we try and call that delay function. Next, we have 2 functions that are very, very similar, upload and download. And these will be things that we can use to either get a file from KSC or to put a file on KSC, the Kerbal Space Center. So we'll just pass it a name, it'll call that delay function, and then it'll check if we currently have a file with that name, and if it's so, we'll delete it. Then it'll check if there's a file with that name at Kerbal Space Center, and if so, it'll copy it. So when we decide, okay, I'm running my mission, I need a new file, I need to know like how to accelerate. Well, I can say, okay, download, accelerate.ks. And we'll go ahead and grab that from the Kerbal Space Center, provided that we have the connection, we're able to do this delay thing. And then as long as this file exists on the hard drive at the Kerbal Space Center, well, that's fine. We can just transmit it to the rocket. And upload would be the same sort of thing. So if we had, logged out some information, I recorded some science. Wow, recorded science. There we go. And, would do something like to, my log text or something like that. Then we could say upload my log text. So this is to get a file from the rocket, and it will go ahead and transmit it off to Kerbal Space Center so we could get it back on the ground. Okay, so those are some helper functions that we've defined, and now we're going to get into the actual logic. So what happens when the machine turns on? Now, this will happen both when we put the thing on the launch pad, and also if we ever switch crafts and jump around and then we go back to this craft, it's going to go ahead and try and run this boot script again. So first, we're going to say we're setting a variable called update script, and we're going to call it shipname plus .update.ks. So for our OmniSat, it would end up being something like omnisat1.update.ks. And this is going to be a file that we're going to look for new instructions from Kerbal Space Center. So first we're going to see if we have a connection, and this comes from the Remote Tech add-on, and it's got a little bit of an integration with Kerbal operating system. So we'll say if we have a connection and the Kerbal Space Center has an update script file for us, well, great. That means that we have new instructions that we need to run. So we'll download that, and then we're going to switch to 0, and so we're going to go here and we're going to delete it off of KSC, because we're assuming that, okay, they wrote this update script and they're transmitting it. We don't need to save a copy, because otherwise we'd try and keep downloading it over and over again. So we'll go ahead and do that. We'll say if we have a file called update.ks, let's delete it. And now we'll rename the file that we just downloaded to update.ks, and then we'll run it. And then once we have run it, we'll go ahead and delete it. So we'll download new instructions that we got from KSC, we'll run it, and then we're gonna delete it immediately, because we're not saving it around. And if the file needs to save something, then we'll have to just make sure that the update script has other download commands. So this will be what happens if we boot this thing on and it knows that it has a connection and there's an update script ready for it. So if we've written new instructions and the ship can know about it, it's going to try and run them. Next, we'll say if there's a file called startup.ks, then we'll go ahead and say, okay, well, we couldn't get a hold of the Space Center, but that's fine. We'll just run a startup script that we have locally. So our update script could say, write this startup.ks file, at which point if we were to reboot again, it'd go ahead and run that. But, by default, this file doesn't exist, so this won't pass. And then finally, if none of those are true, if we don't have a connection and we don't have a local what to do once we start it up, then we're just going to wait until we have a connection. We'll wait an additional 10 seconds to make sure we don't reboot all the time, and then we'll reboot. So what this script is going to do is it's going to say, okay, I'm going to wait for new instructions. If I get them, I'll run them. If I have a startup file, I'll run that. And otherwise, I'm just going to reboot every 10 seconds and keep waiting until until I've got a connection. And this way we can actually write all of our mission steps in separate files and then just name them things like, omnisat1.update.ks. We could say omnisat1.update.ks, and the contents of this file could be something like, print new instructions, stage, and something like that. So it will go ahead and grab this and run it, and then delete it when it is done. So let's look at the first mission script for our Mooner satellite. So our first script is actually very similar to what we initially had launching our satellite network. But instead of actually including these functions here, we are going to download ascent.ks, which is the library that we wrote in a previous episode to handle an automated ascent profile. You see I've got this here on the hard drive, ascent.ks. It's got that execute ascent step. Haven't made any changes to that, so if you're interested or you're coming into this late, you can jump back to the previous episode and take a look at how we did that. So we'll download that file from KSC, and we'll go ahead and run it. We'll set our ascent profile, and this is fairly standard. We've got it, it's a little bit different from how we launched the orbital satellites because the payload's a bit different, but pretty similar. We'll lock the throttle up, wait a second, execute our ascent profile, do all that stuff. We're going to toggle the gear, which is going to turn on our long-range communications and turn off the short-range one. We'll wait till we're close to apoapsis and lock our steering to the horizon, and then throttle all the way up and do all that stuff. And then the last thing we're going to do is we're going to jump into a loop here, and we're going to say, okay, if the max thrust it drops significantly, then our main stage is burnt out, so lock the throttle to 0, wait a second, stage, wait a second, throttle all the way up again. This is just going to get our remaining booster off of the end of our rocket. And then once we've circularized, our periapsis is above the atmosphere, we'll break out of the loop, we'll lock the throttle to 0, and we'll print out that our step is executed, shutting down. So let's go ahead and actually upload that to our vessel. And we're just going to wait a second, let this boot script get its new instructions. Now that we've renamed the Mooner probe update.ks, and there we go, loading the launch script. So it copied our ascent profile library, which is really cool. It means that we'll be able to continue missions without having to write a whole bunch of code from scratch. We can start reusing these things that we've written before. We're getting a lot of wobble because this is a fairly tall craft with not a lot of steering control, but hopefully we should be able to get into orbit. So let's go ahead and shut this down and watch us make our way there. And yes, we had a nominal ascent, so nominal that I ran out of things to say as we were flying. We're not experiencing Mach effects because we're going slower, which of course does mean that we're a little inefficient, but for the sake of stability, we still have plenty of fuel. In fact, we've been deliberately building these rather overpowered to account for the fact that perhaps our scripts are not optimized, and we'll look at improving that in future episodes. But we do discover that we are on a bit of a steep trajectory. We see the side boosters dipping away there, and I start to get a little nervous as we coast up to apoapsis that we may not have enough lateral velocity to actually complete our orbit. Yes, and we see we've got plenty of signal to these satellites, but let's jump back to real time to see if we can make this orbit. It's going to be iffy. And yeah, we're getting dangerously close to apoapsis. Ship, are you... This may not have been the best profile. I think we're skipped... Oh. And yep, we are past it. Okay, please burn faster. You're running out of fuel in here. It's going to be up to this remaining stage to finish the circularization, but only if it doesn't fall back to the planet first. Okay, good. So that's gone. That'll re-enter. That's what we want. We don't want to leave that debris in space, but you are suspiciously. Well, what is your altitude? 78, and so we are falling back toward the planet at a significant rate. It's just a question of whether we can get that periaps up before we fall back into the atmosphere. Ooh, no, maybe. Oh, we're bringing it up. And come on, hey, look at that. And step execute is shutting down. Our first script was a success. Now we have to try and figure out how to get it to there. How do we get over there? And our second script is going to be a little more complicated. We're going to do another transfer burn, just like we did when we were boosting the satellites into a higher orbit. We're going to do the same sort of trick where we compare the longitude, and I've written this function that's going to give us the lunar angle, and I think we could probably clean this up a bit, but we can actually get the longitude of the moon relative to Kerbin by saying body moon. This is similar to in the last video where we said vessel and then gave it a name like Omnisat, and then got the longitude that way. But so we're going to take that, we're going to take the ship longitude, and then I've got some math in here to make sure that we end up with a positive value and some mod operators and stuff. And feel free to take a look on the GitHub repo if you're interested. But the short answer is that this is going to give us the angle of the moon relative to us from 0 to 360. So that's what that function is going to do. I've written another function just because I was tired of typing, these small little margins. This is going to say ish. We're just checking if two variables are the same ish. So we could say like ish 5 and 6 with a margin of error of 2, and that'll say, yeah, true. But if we were to say ish 5 and 6 and with a margin of error of 0.01, then that's going to be false. So this is going to take a first thing and a second thing and ishiness, and we'll say, okay, if the first thing minus the ishiness is less than the second thing, and the first thing plus the ishiness is greater than the second thing, then it's true. So this is just a way, because we can't often do things like, altitude equals 5, because the altitude may equal, 5.01 or 4.9999. And yeah, so this ish function is going to help us out there. Okay, so the stuff we're actually going to do, we're going to wait until we're at the correct lunar angle. We're going to try and come up a little bit behind the moon so that it will keep our orbit relatively sane. We're going to wait until the lunar angle is ish 135 with a margin of error of 0.5 degrees. And then at that point, we will set forward to prograde. We're going to lock the steering to forward, and then we'll throttle up, wait until our apoapsis is greater than the moon's apoapsis. So that's really nice. We don't have to actually type in any numbers there. We'll just say wait until the highest part of our orbit is higher than the highest part of the moon's orbit, and then we know that our orbit will intersect, and then we'll throttle down. We'll say we choose to go to the moon. And the last thing we're going to do is we're going to wait until the ship's orbit's body's name. So this is getting the body that we're currently orbiting around. So right now it's Kerbin, but we're going to use this, which is the same as saying not equals in other languages. We're going to wait until the body name is not Kerbin, which means that we are suddenly orbiting around the moon and not around Kerbin. So we'll say we entered the moon sphere of influence, we'll wait 10 seconds, and then we'll toggle the lights, which is an action group that I've assigned to run all of our science experiments, and we can get all of that near the moon science. Let's try it out. And back to the craft, and now it is just a matter of waiting until we are at the right phase angle with the moon. And this is going to take a little bit, because I tend to leave these things and just kind of let them record rather than try and time warp, for fear that I might time warp past the correct window. But thankfully, I think we're I'm not sure if the moon's going to peak over the horizon. I think we're burning a little bit sooner because we want to catch up on the moon to hopefully make sure that we end up in a good trajectory. But once we get there we go. We see the crazy turning logic, and we start burning, and we can pop out to the map view and see our apoaps slowly and slowly gaining higher and higher, getting us close to the moon. And since we don't have the actual orbits unlocked, we can't actually see if we'll get an encounter, so we're just going to have to trust as we fall out of communications range. But we do indeed encounter the moon, and we get all of our cool sciencey stuff, and we'll go ahead and save all that to return it to the planet Kerbin, and we can watch this hunk of strange rock orbiting the planet, and I don't know, various grandiose things as we say goodbye and see the lunar eclipse as we pass out of the sphere of influence. Of course, now it is just a matter of trying to get ourselves home and making sure that our periaps will indeed encounter the atmosphere, which is going to be interesting. So let's jump in and look at that. Okay, so our descent stage should be pretty easy. All we have to do is make sure that we burn retrograde, so the opposite of the direction that we're heading, when we're close to the apoapsis. And because we're so high up, we should be able to bring our apoapsis down into the atmosphere. So we're going to wait until we're close to the apoapsis. We'll set the direction to retrograde, so the opposite of the direction that we're heading. We'll lock the steering to that, and then we'll throttle all the way up. Then we're going to wait until our periapsis is well within the atmosphere at 55 kilometers. And then we'll throttle down, and we'll lock the steering to retrograde. So this is going to make sure that the engine is facing the atmosphere and will bear the brunt of the re-entry effects. It's still going to be close, but hopefully we'll be able to re-enter without any problems. So we're going to wait then until we get close to the periapsis, and then we'll throttle all the way up and burn out any remaining fuel. And then finally, we'll wait until we're 25 kilometers off the ground and then stage. So we'll ditch that rocket, fly down the rest of the way on our heat shield and our overabundance of parachutes. So let's go and do it. And now we simply have to fly our way down. Now we won't actually get this script uploaded to the craft, but we did get our contract complete, so that's a bit of funds and some science. And we're confident that when we get down there, that hopefully, even though these satellites have kind of drifted out of their orbit, that we will indeed be able to get that script uploaded, at which point it will wait ahead until we get to our apoapsis and start a deorbit. And now it is just a question of whether or not we have enough fuel to actually deorbit and bring this periapsis down. We are going to be coming down pretty darn quick. Oh, look at that. We have another moon encounter. And that broke everything. Oh no. Okay. So we had this thing that when our ETA up, and then it just decided to burn until our lunar periapsis came down. So we are going to get another lunar flyby. All right. We're trying to go there, please. See, we're pointing in the right direction. Let's see what happens. We can warp ahead. I mean, we did burn the fuel now. How much fuel do we have left? Let's bring this back. Oh, we still got plenty of fuel. So as long as we don't get thrown out into space, we should be okay, maybe. Because we can send a fourth set of instructions. Oh, this is a disaster because we spent so much time in space. So yeah, so we're already a week after we launched this mission, and we're still no closer to getting back. We're just revisiting the moon again because we didn't get close enough. Now it's unfortunate because we can't actually get any signal out here. I'd love to be able to do some more science. We could at least get a temperature reading because I think we'll actually be we'll get near mooner science. Look at that. That is just gorgeous. Oh, beautiful. But unfortunately not where we want to be right now. Oh, but look at that. We can see the craters and all that stuff. We shall be returning to... Oh, look at that. We're getting texture and stuff. And even... Oh, that's beautiful. That's got to be the screenshot right there. Which I guess means that I can't just revert this mission. We actually have to try and get this thing home. Alrighty. And yeah, look at that. We're awfully close. Let's see, and we're getting, yeah, so that's the closest point of our orbit. Let's jump ahead and take a look at just how close we are. See, look at that. We can start to see some more of the details of the moon, which is great. And there's a bit of, I guess, shading issues. I don't know, shader issues, something. Where's Kerbal? We've lost track of it. Where'd it go? All right. Well, oh no. What are you trying to do now? This script was not designed for another lunar encounter. Oh boy. Yeah, okay, so that's actually, yes, that's our landing script. Because it assumed that we would be, when we got to the periapsis on Kerbal, then we were going to try and burn off our excess fuel. But it appears, unless maybe we have enough fuel that we don't die. Oh, what are you doing? No. Okay. So this is a good lesson for us all. That we should not. Yes. So plan and make sure that when we are checking our apoapsis and periapsis that we are checking the correct. Oh, all right, good. You staged. Perfect. And these parachutes are ready to deploy as soon as there is some atmosphere. But unfortunately, I do not think it is going to be much help for us today. We will have to try and rectify this in the next episode. We destroyed the moon. All right, I'll take it. We destroyed the moon. Nope, there's the moon. But there is no probe. The poor little probe that was. We will have to rectify this in the next episode. Until then, I will see you soon. Cheers.